In today's lessons, we are going to learn how to factor expressions. You guys each have a note sheet with you. I'm going to ask you to not write anything on that note sheet yet. I just want to give you an example of what we're going to be learning, and then you'll have plenty of chances to write this down. So we're going to start off, if I gave you the expression 4 times x minus 3. We've worked in the past where you've been asked to simplify this expression. And we know that we do so using the distributive property. So I would do 4 times x, and then I would do 4 times 3. And my new expression would be 4x minus 12. So what we're going to start doing today is we're going to go backwards. So as of today, I'm going to give you this expression, and I'm going to ask you to factor it. And when you factor an expression, you're putting it back in its original form. I want you to think of the word factor as a synonym for division. So when I ask you to factor, I'd be looking at the terms 4x and 12 and thinking, what can I divide out of both of those terms? So I see a 4x and a 12. 4 is the GCF. The GCF is always the term outside the parenthesis. If I divide 4 out of 4x, I'm left with x. If I divide 4 out of 12, I'm left with 3. And whatever operational symbol is there in the beginning, we're just going to keep. So that's how we factor. And I'm going to show you, you can still use your cake method that we've been working with. So if you now go into box 1 on your note sheet, our first example is the expression 8x plus 56. If I factor 8x plus 56, again, I'm thinking, what's the biggest term that I can pull out of both of these? And that would be an 8. If I divide 8 out of 8x, I'm left with x. If I divide 8 out of 56, I'm left with 7. Looking at this layer of cake, x and 7 don't have anything in common. So 8 is my GCF. And then the expression left over after we divide out the 8, which happens to also be your smallest layer of cake, goes inside the parenthesis. So my factored expression is 8 times the quantity x plus 7. And I could easily check this. If I distribute, I will get my original equation back. Let's jump into box number 2. And when there's terms like these that include exponents, I recommend at this point that we do use our cake method and we don't try to do it mentally. So I'm going to rewrite these terms without their exponents. So we have 15xxy and 24xyy. I'm going to draw my first bar of cake. And I like to always start with my numbers. So if I look at 15 and 24, I can factor out a 3. And that would leave me with a 5, xxy. And then if I divide 24 by 3, I'm going to be left with 8, xyy. Now 5 and 8 do not have anything in common. So I'm now going to look at my variables, and I see that each of these terms has an x and a y. So I'm going to pull out both one x and one y. And in doing so, I've gotten rid of these, and I've gotten rid of these. So my next layer is just going to be a 5x and an 8y. And notice I'm just going to keep bringing down that subtraction sign so that I don't forget about it. 5x and 8y have no terms in common. So at this point, I am ready to put together my factored expression. So I take the side terms, which is 3xy, that's my GCF, and I multiply that by my bottom layer of cake. And there's your factored expression. Let's move to box 3. Again, I'm going to rewrite these so that they don't have an exponent. So 30x y, 55x, xy. Looking at my numbers, 30 and 55 can both be divided by 5. And that would leave me, 30 divided by 5 is 6. Bring down all those letters. And then 55 divided by 5 is 11. And again, I bring down the terms for the variables. I'm going to add another layer here. 6 and 11 have nothing in common, but I now see that I can pull out one x and one y. And if it helps you to identify what you're pulling out, go ahead and do so. So I'm pulling out this x and this y, and I'm pulling out an x and a y. So they're no longer there. So what I'm left with is 6yy and 11x. There's nothing further in common between the terms. So at this point I write my factored expression, grabbing my GCF from the side, and then the remaining expression goes inside. So 6yy plus 11x. And when you get to this point, if you'd prefer to write y squared, you absolutely may. We're going to do one more together. So in box 4, again, I'm going to start off getting rid of that exponent. So 14aabc minus 24ac. 14 and 24 have a common factor of 2, which leaves me with 7aabc minus 12ac. 7 and 12 don't have any common factors, but I have an a and a c in both of these terms. So I'm going to factor out or divide out the a and the c. So what I'm left with now is 7ab minus 12c. Oh, I'm lying. Minus 12. We factored out that c. 7ab and 12 don't have anything in common, so my cake is finished. I'll just draw my last layer here. And then I'm going to take my GCF off the side, which is 2ac, and I'm going to multiply it by my bottom layer of cake. And that's my factored expression. So what I'd like you to do at this point, on the bottom of your page, you have 3 boxes where it says try it. I'm going to ask you to pause this video, try these 3, and then when you're ready to check your answers, you can go ahead and press play, and I will have the answers for you. Okay, so now that you have those done, let's check your work. For the first one, we should have 11xy times 5y squared plus 7x squared. For the second one, you should have 8ab squared times 2 minus 5a. And for the last one, 5 times the quantity 4x cubed plus 7y squared. And again, if you want to write these with exponents, you're absolutely welcome to. So that completes our lesson. You guys can ignore the back portion of your note sheet. If you want to cross that out, that's fine. And you're now going to complete some practice.